Hello, my name is Farzaan Siddiqui, and today I'm going to be explaining the design of an external door opener. Here is a proposed design for a door opener. It is operated by either pushing down the top piston or stepping on the lever at the bottom. Performing any one of these movements causes the hydraulic rod to extend and thus opening the door. Here is a demonstration of the mechanism. As the piston is pushed down, the hydraulic rod is extended, and the force of the rod pushes the door open. When the force on the piston is released, the rod collapses and the door closes. This simple operation of only one step is how the mechanism operates. Now, why would we need such an addition to an item as simple as a door? Passing through an entrance can be accomplished by just pushing or pulling the handle. To answer that, we need to first examine situations that are not ideal, but very common. Imagine you are walking towards a building, and you are making your way towards the entrance. You are also carrying with you a large, heavy box with both hands. You approach the entrance, and it is a standard door with a regular handle that you pull to open. But there's one problem. Unfortunately, you can't proceed forward because there is no way for you to open the door while both your hands are busy carrying the large, heavy box. Now imagine if there was some way to open the door, even when you can't use your arms. Such a method, if it did exist, would save any time wasted, it would increase productivity, and most of all, it would be more convenient. Another reason this design change is necessary is because of the benefit it brings to people that require handicap assist resources. Imagine we have a person in a wheelchair that is approaching the same building in the previous example. This entrance also has a door with a regular handle that you pull to open. Since the person is in a wheelchair, it is very awkward to open the door while also maneuvering around to make space for the door to open. Even though this person is able to use their arms, it's still difficult to open the door from their current position. To resolve any of these issues, entrances will usually be equipped with electronic door openers. These systems consist of pressing a button from an easily accessible height that activates the mechanism. The problem with this application is that it relies on electrical components. The system is still susceptible to electrical issues or even motor issues in other components. Overall, the automated door openers can have unforeseen issues that null the entire function. The solution would be to have a system that can operate without any need for electrical power. We will now discuss what a solution to this problem looks like. Here is a 3D modeled prototype of the external door opener. We can simplify this design into 3 different sub-assemblies. They are the piston subassembly, the rod subassembly, and the hose subassembly. Now let's further discuss what each of these subassemblies are responsible for. The piston subassembly has 2 piston cylinders that extend outward. The cylinder on top of the base is meant to be pushed downward using your hand. The cylinder on the bottom of the base has a stepping plane that is linked to a piston arm. This piece is meant to be pushed down by stepping on it. Both of these pistons are part of a larger hydraulic system that controls the whole mechanism. The rod subassembly has 8 rubber tubes that are connected and extend similar to a telescope. The end of the final tube has an adapter that is fastened to 2 linking arms that will eventually connect to the end of the door. When the piston assembly experiences a force, the rod subassembly will use that force to expand its volume and extend the rod. This will divert the force on the piston into pushing the door open. The hose subassembly is the bridge between the 2 previous assemblies. It links the 2 components and completes the overall hydraulic system. When a force is applied, the fluid within the system is forced out of the piston subassembly, passes through the hose, and enters the rod. This mechanism is very simple and works effectively, but how is it able to work? To understand that, we need to understand how the hydraulic system operates. Liquids such as water are incompressible. What does that mean? As the name suggests, these liquids can't be compressed, unlike gases that are compressible. Let's imagine we have 2 syringes that are connected by a tube. Inside this tube is water that connects both of these syringes. If we press down one of these syringes, we will see that water will move along the tube and the other syringe will appear to extend. This is because when a force is applied to the water, that pressure will be seen in all parts of the water. However, this principle won't hold if there's air in the system. That is because air is once again compressible, so the system must be airtight. We will now discuss the manufacturing processes that all these components require. The hose, piston cylinders, and stepping plane will be created through injection molding. The material to be used will be acrylonitrile butadiene styrene, or ABS plastic. It's a low-cost thermoplastic that has a high strength and very high durability. The tubes for the rod assembly and the base will also be created through injection molding. However, the material used for these components will be polycarbonate plastic, or PC plastic. This material is lightweight and can maintain its properties over a wide temperature range. It's waterproof and can be used in weather conditions, which is perfect because this mechanism will be outdoors. The linking arms, pins, and hinge that connect to the door will be metal stamped. They are simple components that don't need to be manufactured in an expensive way. They can be made cost effectively. After examining each of the components that make up the prototype, we can now understand how it functions. This mechanism can help bring a great change for the task it's designed for. If we look at the previous examples from earlier in the video, we have the same person that wants to enter through a doorway, but is busy holding a large heavy box. Now he can move towards the door opener, step on the plane to apply force, and watch as the door opens. He has successfully created a path to walk through without using his hands. In the other example, we have the same person that is confined in a wheelchair. Instead of dealing with electrical devices or awkward movements, this person can just move towards the door opener, press down on the piston, and watch as the door opens with plenty of space. Now this person doesn't have to deal with maneuvering in awkward positions to open the door and get out of its way. Overall, this proves to be a good design change. The external door opener can achieve its goal of covering potential faults and bringing convenience to the user. Here are the references used for making this video. That is all. Thank you for watching.